Previously on Virtual Math with Mr. Ferrara. Circumference. Formula, pi times diameter. That's the distance around the circle. Second formula is area, which is pi r squared. That's the amount of space inside the shape. The next word is going to be important in this chapter. It's called a chord. That's a segment connecting one side of the circle to the other. Diameter is a chord passing from one side of the circle to the other through the center. So the diameter is the longest chord within a circle. All diameters are chords, but all chords are non-diameters. Radius extends from the center of the circle outwards to the edge of the circle. In this circle, one radius is OC. It's Virtual Math with Mr. Ferrara.
Oh hey, I didn't see you there. I was just about to get started with our geometry lesson. If you'd like to join in, print out the PowerPoint and work out the problems with me. All right, hopefully everything goes well. Let's get started.
Hey, what's up everybody? Today we're going to be talking about tangent lines. If you're following along in your textbook at home, this is section 10.2. The first thing we need to start with is, what is a tangent? So imagine a circle like the one you see on the screen. Imagine I draw a line grazing by the circle and only touching that circle at one point, not going through the circle, not missing the circle, only touching the circle at one point, in this case, point Y. That line that I drew in is called the tangent line. The definition: a line on the same plane as the circle that intersects the circle at exactly one point. In this picture, point Y is where the tangent line touches the circle. That point is called the point of tangency. The point of tangency is where the line and the circle intersect. Now, there are some facts that happen when we draw in a tangent line with a point of tangency. One of those facts is this theorem. If a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. Again, if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. Look at the circle in the middle of the screen. Imagine I draw a radius. Then I draw a tangent line that intersects the circle at exactly where that radius intersected the circle. That point makes a right angle. So there's a right angle between OP and AB. So again, if I draw in a radius, I draw in a tangent line. If both of them intersect at the same point, that's a right angle created.
Let's jump right into some examples dealing with tangent lines and points of tangency. Example 1 says, solve for x given that the circle has center A and point B is the point of tangency. The minute I hear point of tangency, I'm looking for right angles. Well, this is a right angle because the radius and the tangent line always make a right angle. Now that I know two angles of the triangle and I'm looking for the third angle, I know because of the triangle angle sum theorem that three angles always add up to be 180 degrees. So I can say 22 degrees plus 90 degrees plus x degrees equals 180 degrees. Combine 22 and 90, you get 112 plus x equals 180. Subtract 112 from both sides, you get the missing central angle to be 68 degrees. Again, because of the triangle angle sum theorem, this is a 90-degree angle because of point of tangencies, and we get 68 degrees. Example 2, says find the measure of angle E given that DE and EF are tangents to circle C. Again, the minute you see tangent, you're looking for radiuses, and I do have a radius extending out, which means that this is a right angle here, and this is a right angle here. Here's a bonus question that's not on here. What shape is CDEF? Hopefully you said that shape is a kite. It's a kite because this and this are equal, and we find out later on that these two are equal as well. Since this is a kite, we know that there's 360 degrees in any quadrilateral. So we know that 110 degrees plus angle D is 90 degrees, plus angle F is 90 degrees, plus X equals 360 degrees. Add these up. 110 plus 90 is 290 degrees, plus X equals 360 degrees. Subtract 290 from both sides. You get our missing angle E to be 70 degrees. So you're always looking for points of tangency meeting up with radius, because when they do, you form right angles. Now, this problem should look somewhat familiar. Problem 3 should look somewhat familiar. We had it on a test a couple months ago. Finding the distance between centers, given point A and B are points of tangency of these circles. If this is a radius and this is a point of tangency, there's a right angle here. This is a radius, this is a point of tangency, so this is 90 degrees. Now, if this is a straight line, even if I slide it straight down this way, I still create the same length line this way. When I slide this 12-inch line down the radius, I still form a 12-inch line. Since this is a right angle here, sliding it down still makes a right angle here. If this section is 4 inches, slide it across this way, this section from here to here is still 4 inches. However, this radius is 10, and if this section's 4, that means this part of the radius is 6. I've now created a right triangle, and the distance between X and Y is the hypotenuse of that right triangle. We can now solve the Pythagorean theorem with 6 being one leg, 12 being the other leg, and this distance here being C. Sometimes it helps to look at it this way, where the right angle is in the bottom corner, and this is the right triangle that I'm solving for. So 6 squared is 36, 12 squared is 144, and that equals C squared. 36 plus 144 is 180, equals C squared. While we're here, let's work on simplifying square roots, because we need to square root both sides. The square root of 180 can be broken into 2 numbers, one of which is a perfect square. 180 can be broken into 36 and 5. The square root of 36 is 6 radical 5. And 6 times radical 5, if you needed it in decimal form, is 13.4. So the distance between X and Y is 13.4. Here's the final type of example that you can deal with. Examples similar to these. The question is ML tangent to circle N? If this was a radius and this line was tangent, that would mean that this would have to be a right angle. Do we know that's a right angle? In this picture, we don't know it's a right angle until we prove it. In order to prove that's a right angle, this triangle would need to be a right triangle. So if I look, I have a 7 for a radius, I have a 24 for a leg. I need to know if the hypotenuse is going to be this length right here. Now I'm missing this part right here. That part is also a radius, so that part is 7. Now I have all three sides and I need to verify if that triangle is a right triangle. Is 7 squared plus 24 squared, is that equal to this entire length, 25 squared? Well, I know that 7 squared is 49. I know that 24 squared is 576. I also know that 25 squared is 625. So is 49 plus 576 equal to 625? I do find out that 625 does equal 625. So is ML tangent to circle N? The answer to that is yes, because it makes a right angle. Now, hopefully you remember some of your algebra, because for the last problem on these type of problems, we have solving for x, but x is this section outside of the circle. So again, we're trying to verify. We already know that this is a right angle, so let's set up the Pythagorean theorem. 6 squared plus 8 squared equals this entire hypotenuse, which is x plus 6 squared. Easy part first, 36 plus 64. Hopefully you remember how to do FOIL, first, outer, inner, last, or you could draw Punnett squares. I'm going to use x plus 6 times x plus 6, and I'm going to use FOIL. X times x, x squared. X times 6, 6x. 6 times x, 6x. And 6 times 6, 36. Bring down my 36 plus 64, which is 100. I now have a messy equation that I want to start cleaning up. X squared stays x squared. 6x plus 6x is 12x. And I'm going to slide this 100 over to the other side by subtracting. 36 minus 100 is negative 64. And when I slid that 100 over by subtracting, I'm left with 0 on this side. Well, now that helps me because now I can factor. I need to find a number that multiplies to be negative 64, but then add together to be 12. So I'm going to set up my x factor. Negative 64 goes up top, 12 goes out the bottom. I need two numbers that will multiply to be negative 64, but add to be positive 12. So two numbers that multiply to be negative 64, that could be negative 1 and 64, that could be 2 and 32, that could be 4 and 16, and 4 and 16 is the one that helps us. Negative 4 times a positive 16. The way I know that it's a negative 4 is because these need to add to be a positive number, so therefore the bigger number needs to be positive. So now I can factor that and use x minus 4 equals 0 and x plus 16 equals 0. Add 4 to both sides, you get x equals 4. Subtract 16, you get x equals negative 16. So there are two answers to this quadratic, x equals 4 and x equals negative 16. Only one of those can be used in the geometry problem. Which one is it? Hopefully you said x minus 16 cannot be used because this section right here cannot be negative 16. That would not make any sense. So our answer to this problem is 4 and only 4.
The second part of this section deals with inscribed circles. An inscribed circle is a circle that's drawn inside of the triangle, like the one you see on the screen. Since the circle is only touching the triangle in 3 spots, those 3 spots are tangent to the circle. 1, 2, 3. Now there is a theorem that goes along with that. 2 segments tangent to a circle from a point outside of that circle are congruent to each other. So imagine point A. Imagine I connect point A to the tangent B on the circle, and take point A and connect it to tangent point C on the circle. If I do that, AB is congruent to AC. So if AB was 10, AC is also 10.
All right, last example, example 6. Fairly easy example, standard type of problem using this theorem. If this is 4, this is 8, and this is 10, we're able to find all the missing sides. So x, using the last theorem we talked about, is also 10. Y, using that same theorem, is 4, and z is 8. So now we have all the missing sides. We can now find the perimeter by adding 4 plus 4 plus 10 plus 10 plus 8 plus 8 to get a perimeter of that triangle to be 44. Easy example. Hopefully this all made sense. Try the classwork that's been assigned to you. If you have any questions, please ask in the live conferences. You can Schoology message me, you can email me, or you can call the Google helpline. Hopefully everything makes sense. I look forward to talking to you soon. Bye.